I love this machine with its brass cogs and wheels and things. It was built over 100 years ago, and even then it was capable of predicting the tides anywhere in the world.
Right, so it's been used quite a lot then?
It's been used for a very long time. In fact, it was used to predict the tides during the D-Day landings.
Right, so how does it actually work? Is it all the wheels and the little wires and things?
That's right, and there are cogs at the back, so it's basically clockwork behind the board that you see. And that works because the sun and the moon are like clockwork in the way they move around the Earth. So you can simulate the effect they have on the ocean.
Right, so this can show us how the ocean moves up and down.
That's right, yeah.
Right, so is there anything still left to do? If this shows us how the ocean moves up and down, what more do we need to know?
Well, we're talking about the tides, and when oceanographers talk about tides, they mean particularly that part that's associated with the sun and the moon and these regular motions. But there are irregular motions as well, and those are associated with the weather.
Right, so the wind, the waves, the ocean itself?
Well, all of those. The weather in the atmosphere produces wind that pushes the water around, and we call that a storm surge when it creates a sea level change. But the ocean has its own weather as well.
Right, so what is this ocean weather?
Well, I can show you. What you see here is sea level after the tides have been taken out. So the oranges and the reds are high sea level, and the blues and the purples are low sea level. In fact, there's more than 3 meters of difference between the sea level up here around Japan and the sea level down around Antarctica. And it's the ocean currents associated with that sea level that are the ocean weather.
Right, so what are all these little black dots winding everywhere?
Well, those are telling you what the ocean currents are doing. Those are drifters. A drifter is like a little buoy that floats on the sea surface and a huge windsock that hangs from it so that the drifter is actually following the water rather than being pushed around by the wind.
Right, so that will get dragged around by what the currents are doing?
That's right, yes.
Right, so if you've got this higher sea level near the equator, then why doesn't the water just flow down to where it's lower?
It is odd, isn't it? It's not what you'd expect. And that's because of the Earth's rotation, because the Earth's spinning. So these currents, if they last more than a day or so, they're actually going round in circles once a day. Now, it's just like your tea. If you look at what goes on when you stir a cup of tea, give it a stir, the tea's going round in circles and there's a dip in the middle. So rather than the tea flowing down into the middle, it's flowing round, and that's exactly what you're seeing here.
Ah, right, so is that why you see the little dots following along the edge of the green down in the South Ocean?
Exactly. The dots don't flow from high to low sea level, they flow along the contours. So the contours look like a map of the ocean currents.